along on the sheets I gave you. All the definitions are down there for you. So if you just want to read along as I read. Inferential statistics, what those are is that's where a sample of data is analyzed and conclusions are made about the population. Where do you get that? Because the root word of inferential is inference. Okay, when you make an inference about something. The parameter is a measure that describes a characteristic of a population. Okay. We also have a point estimate, which is a single value estimate of an unknown population parameter, and an interval estimate, which is a range of values used to estimate an unknown population parameter. Okay, so those are the definitions from today's section. Now what we're going to do is we're going to talk about what, in fact, are confidence levels, and this is what we're going to do entirely today. Okay, a confidence level is the probability that the interval estimate will include the actual population parameter. So basically what that means is you can assert with like 99% confidence that the value will be in this interval. Or you can assert with 95% confidence that the value will be within this interval. And so in order to find a confidence interval, we need to know the maximum error of estimate. That is abbreviated as E. And that is the maximum difference between the point estimate and the actual value of the parameter. So you're probably utterly confused right now. Don't worry about it. What I need you to take from this is I need you to take these formulas right here. Okay? E equals Z times the standard deviation of the mean, or Z times the standard deviation divided by root n. Okay? So go ahead and make sure you highlight those. I've got to get my plug-in real quick. Okay, so now what we're going to do is we're going to look at a few examples. Like I said, those of you that have the note sheet, you're going to notice it's small print. Sorry, that's how it came out. Okay, but at least you don't have to write them down. Okay, so let's go ahead and look at this first example. Actually, I take that back. We're going to look at critical values first. These are some values that you might want to get down. Okay, the first one is a 90% confidence level, which has a Z value of 1.645, 95, which is 1.960, and 99, which is 2.576. If it's not one of these three, say, for example, it was like 94% or 98% or anything other than what's in the table, we are going to use the inverse norm feature on our calculator. And we'll actually have an example of that. So if it's not any one of these three, you are going to use the inverse norm feature on your calculator. And in fact, we will do that on 2 of our examples today. All right, so example 1 says a poll of 75 randomly selected college students showed that the students spent an average of $230 on textbooks per session. Assume from past studies that the standard deviation is $55. Use a 99% confidence level to find the maximum error of estimate for the amount of money spent by students on textbooks. Okay. So what we need to do is use that formula. E equals, okay, our Z value. And in this case, since they're dealing with a sample, we're going to use this formula right here. And all we have to do is plug in what we know. It's a 99% confidence level. So from your table, what does 99% correlate to? 2.576, you said? What is the standard deviation in this problem? What does it say? 55. Divided by the square root of. How many people did we poll? 75. All we have to do now is calculate that, and that's our answer. That's our maximum error of estimate. So 2.576 times 55 divided by the square root of 75. And what do you get? I want to go to 3 decimal places, please. 360. Good. So the maximum error of estimate for the amount of money would actually be $16.36. All right, questions? Let's look at the next example. Executives at a music label surveyed 125 people who actively download music and found that the listeners have an average of 740 MP3s downloaded to their computers. Assume a standard deviation of 86 MP3s. Use a 94% confidence level to find the maximum error of estimate for the amount of MP3s on the computer of someone who actively downloads music. Now this is exactly like the problem before. The difference is what? Yeah, inverse norm, because you want a 94% confidence level. So we need to go ahead and draw this out. And if I draw this out, what this means is that I want the majority of the data to be here, 94%. Okay? And if I want the majority of data to be there, what percent is left for the other two areas? 3%. Very good. So what I'm finding is I'm actually going to find this value on the right. This is the value you always take. And so what percent would be to the left of that? 97%. So when you do this on your calculator, you're going to do inverse norm of 97%. Actually, so it would be 0.97. Okay? So remember, we find inverse norm by doing second and the bars button. Go ahead and do inverse norm of 0.97. And remember, we always do 0, 1 at the end. And what does the inverse norm calculate to 3 decimal places to be? 1.881. Very good. So now that's the value I'm going to use. So remember from the slide before, I'm going to take z, okay, times the standard deviation divided by root n. So in this case, 1.881. What's the standard deviation? 86 divided by root 125. So what does that come out to be? 14 point what? You're right. 469. Yep. There you go. Okay, questions? Pretty straightforward. If you can do what we just did, that's all we're doing today. Okay, we've got to add one little more piece to the puzzle, and that's what's now a confidence interval. Basically, a confidence interval is a specific interval estimate of a parameter. It's found when the maximum error of estimate, which we just got done finding, is added to and subtracted to the sample mean. So basically, all we're doing is we're finding what we found, and then now what we're going to do is place it within the mean. We're going to add and subtract it from the mean, and we call that a confidence interval. So let's look at this one. A poll of 20 randomly selected high school students showed that the students spent a mean time of 35 minutes per weeknight on homework. Assume a normal distribution with a standard deviation of 12 minutes. Find a 90% confidence interval for the mean of all students. So the first thing you're going to do is you're going to find the maximum error of estimate. So how we do that is I take z times the standard deviation divided by root n. What's our z value here? 1.645. For those of you wondering where that came from, that correlates to the 90% confidence interval on that table. Okay? Standard deviation is 12 divided by square root of 20. So I need you to go ahead and calculate that for me and tell me what you get. 4.414, very good. And so now we need to find a confidence interval. So what I'm going to do now is I'm going to now use the mean. And the mean in this problem was 35. So all I'm going to do is I'm going to do this. 35 plus or minus 4.414. And so that's what you need to do. The first thing we're going to do is subtract, though, because that'll give us a smaller value. And when I subtract, what do I get? 30.586. What's my next one going to be? There you go. So here's the confidence interval. That's it. It's the exact same thing we've been doing, we're just adding and subtracting it from the mean. Questions? Pretty straightforward. Okay, let's look at the next one. A sample of 65 randomly selected mall patrons showed that they spent an average of $70 that day. Assume a standard deviation of $12. Find a 95% confidence interval for the average amount spent by a mall patron that day. First thing, find the maximum error of estimate. So what's my z-value going to be? 1.960 times what? 12 over root 60. Very good. What does it come out to be?
It's over root 65.
Oh, root 65. Sorry. So what did you get? 2.917. Good. So now all I'm going to do is I'm going to take the mean, which in this problem is 70, and I'm going to add or subtract, in this case, $2.92. The reason why I rounded to 2 decimal places is because we're dealing with money. 67, okay. 6708 to what? $70. Too close. $72.92. There you go. Questions? Okay, the next one's a little different, so that's why we're going to go ahead and look at that one. It says tensile strength is the stress at which material breaks or deforms. A company wants to estimate the mean tensile strength of a new material. A random sample of 40 units is normally distributed with an average tensile strength of 36.3 KSI, or 36,300 pounds per square inch, and a standard deviation of 2.9 KSI. Find a 98% confidence interval for the mean tensile strength of the material. So very first thing, we've got to find what 98% correlates to. Okay, so what that means is that this has to be 98%, right? What has to be on each of the other sides? 1%. So when I type this in and use the inverse norm, what am I going to take the inverse norm of? 99. Very good. Oh, let's go ahead and write that up. So when you do that on your calculator to 3 decimal places, what does that appear to be? 2.326. Okay, so now I've got to find the maximum error of estimate. So I'm going to take 2.326 times what? 2.9 over square root of 40. Okay? What does that come out to be? 1.067. Good. And so now I need to go ahead and use my mean, which my mean is what? Yep, 36.3, and then I'm going to add or subtract 1.067. Now when I do that, I end up getting 35.233 KSI to 37.367 KSI. So that would be a 98% confidence interval. That's it today. Questions? I know I have one more there. Do we need to look at it or not? Okay. I think we've kind of hit those. This is what I need you to do on page 702 through 703. I need you to do 1 through 18. Okay?